So in part C of the problem, we have another small bead of mass, little m, which is initially moving with velocity v0 to the right. It then collides with the original bead of mass m, which is sitting at rest at x equals 0, and the two beads then stick together and move to the right. And we're asked to figure out for what value of x do the two beads then come instantaneously to rest. So since we can assume that x is much, much less than L0, we can use our result of potential energy that we derived in part B of the problem. So let's start off by figuring out what happened before and after the right before and right after the collision. So right before the collision, we have our second bead of mass, little m, traveling to the right with speed v0, and our first bead sitting at rest. Now, right after the collision, our two beads are going to stick together and move together with speed v to the right. So by conservation of momentum, we have that the initial momentum mv0 is going to be equal to the final momentum, which is the total mass 2m times v. So this means that the speed of the two beads right after the collision happens, so at x equals 0, is going to be given by mv0 over 2m, which is just v0 over 2. Now, since the two beads slide without friction, then mechanical energy of our system is conserved. So since the springs are unstretched at x equals 0, all of the mechanical energy initially is going to be kinetic. Now when the two beads come instantaneously to rest at x, then the potential energy at that value of x is going to be equal to the total mechanical energy of the system, since our system won't have kinetic energy when they're at rest. So this means that the kinetic energy K is going to, at x equals 0, so let's call it K0, that's going to be equal to the potential energy at the value of x for which the two beads come instantaneously to rest. So let's figure out what K0 is. Well, K0 is just going to be half of the total mass of our system, which is 2m, times the initial speed of our system at x equals 0. So that's going to be given by v, which is v0 over 2, and that's squared. So simplifying, we get that the kinetic energy at x equals 0 is mv0 squared over 4. And that's going to be equal to the potential energy at x, which is going to be given by k times x to the 4 over 4 L0 squared. So x to the 4 is going to be equal to 4 L0 squared over k times mv0 squared over 4, which is just m L0 squared v0 squared over k. So our final answer for x is going to be m times L0 squared times v0 squared over k, all to the 1/4. So this value of x, the two beads will come instantaneously to rest.